This is part 3 of lesson 4.2 on rational exponents and radicals. Okay, the last part of this lesson we're going to review what we know about radicals already. So remember, we have square root, we have cube root, and we can have other roots as well. So we learned last year how to simplify radicals, and so just to review that, if we have the square root of 18, that's the same as the square root of 2 times 9. And remember, we learned that if you have a pair, that can come out, so you're going to have 3 square root 2, and that's the answer to square root 18. That's the simplified version of it. So I'm just going to write that right here. Okay, number 32, the square root of 40. So that's going to be the square root of 4 times 10. So that's the square root of 4 times 10. I'm going to take out a pair of 2's. I'm going to have 2 square root 10. Number 33, we have learned in just the last lesson that if we have the square root of a negative number, in the real number system, that's undefined. So if you put that in your calculator, it's going to say error or something like that. However, if we talk about complex numbers, imaginary numbers, we can do this now. So the square root of negative 3, that's going to be the square root of negative 1 times 3. And we learned that negative 1 is the same as I times 3. So I can take out a pair of i's. And so what this is going to be equal to is it's going to be equal to I square root 3. And so that's the simplified radical for square root negative 3. So that, of course, is an imaginary number or a complex number. A complex number has a real number part and imaginary number part. So this really has a real number part like that, and then the imaginary number part is like that. So when you have a radical with an imaginary, you write the I first and then the radical part. Don't do it the other way around. So you're not going to write square root 3i, because then it's hard to tell a lot of times if the I is under the radical or not, and it does matter. Okay, number 34. It is a cube root, so that means that in order to take anything out of my radical, I'm going to have 3 of anything. So here I do have that, and so that's going to be equal to 2. Number 35, cube root of 40. So 40 is 4 times 10. I do have a set of 3, so I'm going to have 2 cube root 5. And for the fourth root of 40, if you were to write that out, you've got 4 times 10. You do not have 4 of anything, so just wrap it up back together, and that's what it's going to be. All right, let's approximate the value. So without using a calculator, let's put each of these numbers on the number line, approximate where they're supposed to be. So A is the square root of 16. Of course, we know that that's equal to 4. So that one is pretty easy. So I'm just going to put the letter A right there. B is the square root of 25, and so that's 5. C is negative square root 9. So since the negative is outside, it's just going to be negative, and then square root of 9 is 3. So negative 3 is going to go right there on the number line. Okay, now it gets a little bit harder now with D square root of 23. I know that 23 is between the square numbers of 16 and 25. So I know that on the number line, it's going to be between the square root of 16 and the square root of 25. So it's going to be between 4 and 5. So D is going to be right in here somewhere. Okay, the next one, the square root of negative 8. So that's going to be negative, and then 8 is 2 times 2 times 2. So you're going to have negative 2 square root 2. So you're going to have negative 2, and then the square root of 2, let's do this. Square root of 2 is going to be between square root 4 and square root 1. So that's going to be between 1 and 2. So it's going to be 1 point something. So 2 times, not quite 2, but more than 1. So it's going to be between 2 and 3. So if it was like 1.5, let's say, it would be negative 3. And if it was 1.2, it would be between 2 and 3. So it's going to be somewhere in here. Oh, and it is negative. I did say negative. Okay, so it's going to be somewhere in here. The biggest it could be, the smallest it could be is negative 4, because if it was a negative 2, which we know it's not, if square root 2 is a negative 2, which it's not. It would be -4. I don't know if that really makes sense. Anyway, it's good to know about what square root 2 is. So you can put that in your calculator and find out. It's about 1.4. And so that's just good to know. So it's actually going to be closer to the 3, right about there. So we'll just put E right there. And then negative square root 4, of course, is -2. So we're going to put that D right. Oh, there's another D. That should be something else. F. Okay, what is the same about all 4 of the expressions, and what is different about the 4 expressions? Actually, there's 6 expressions. So with these 6 expressions, what is the same? So you might have thought they're all on the number line, which is true, they all are, okay? And the reason that they're all on the number line is because they're all real numbers. Okay, as far as what is different, what was different? We noticed that these first ones right there and this one right here, those were integers, but then some were not. Specifically, the ones that were not integers, if you remember, they're called irrational numbers. Because if you have something like square root 2, that's irrational because if you look at the decimal, there's no pattern and it never ends. So we have some of them being rational numbers and some of them being irrational numbers. It just so happens that all of the ones that are rational are also integers this time. Although if we had one that was 1/2, that would be rational but not an integer. So the reason we're talking about all of this is because we are going to start talking about some irrational numbers and how that relates to our exponents. So if we simplify our radical expression, so just to review a little bit, cube root of 125, that's 5 times 25. So you can pause this real quick and do this yourself because you have already learned how to do this. And then you just come back and check and make sure you're right. Okay, this is what I have for 38 and 39. If you look at number 40, I wrote it all out. I expanded everything in there. I'm going to take out the pair of 3's. And then I look at my x's. I've got a pair of x's, a pair of y's, and another pair of y's. I still have one of the y's that's going to have to stay. Looking at my z's, I've got 4 pairs of them. So I'm going to have z to the 4th power, but one has to stay put. So this would be my simplified radical. Okay, a couple more. Go ahead and do these. Okay, for 41 and 42, I've got that written out, and you can see what I did. Do not forget that when you're doing a cube root, you have to put the little 3 in the radical there. If you forget to do that, then that's a square root, and that means something different. One other idea I'm just going to throw in here, because sometimes you see this, is for any real number, if you have the nth root of a to the n, we already know that those basically cancel each other out, so it's equal to a. However, there is one idea here that if n is an odd power, so if you have like a to the 3rd power or 3rd root of a to the 3rd, it's actually going to be a, because if you think about like -8 to the 3rd power or 3rd root of -8, it's going to be -2. It cannot be +2. No way. However, if you have something like the square root of 3 to the 2nd power, or not 3 to the 2nd power, a to the 2nd power, it actually, a could be a positive or a negative number, because if you think about like if it was, like 4 to the 2nd power, then you'd be talking about the square root of 16. If it was -4 to the 2nd power, you'd also be talking about 16. So one thing that we could say is that a is the absolute value if the exponent is even. And so this goes back to that idea of like positive times a positive is positive, negative times negative is negative, but if you have one of each, it's going to be negative. So on number 43, I have the square root. Now the square root of 4 is just 2. Actually, let me write that. So I'm going to have 2. Now x to the 4th power, I've got 2 sets, so that's going to come out, but it's going to be the absolute value of x to the 2nd power. We'll come back and talk about that in a second. Y, I've got 2 of those, so that's going to come out, and that's going to be absolute value because that's an even exponent. And then z, I have how many sets are going to come out. So z to the fourth power, and it's the absolute value of z. Now, it's kind of an interesting thing because then when we turn it around, if I have x and it's to the second power, does it matter if x is positive or negative? It doesn't. Same with z, it's to the fourth power, so it doesn't matter if it's positive or negative. Of course, anything to the fourth power is going to come out positive anyway, so we can just write z to the fourth without worrying about that. Now, if we look up here, if n is odd, then we can just write a, or in this case y, so I'm okay to write that for my answer. Let's go to number 44. I'm going to have a third root, and so since our n is odd, n is 3, I don't have to worry about any of the absolute value stuff, so I'm just going to go ahead and do what I would do. That's the answer there. Okay, now number 45, we do have a square root there, so there's a 2, and so n is even, and so I have to worry about what's going to come out here. So another way to think about this is to say square root of 63, so 63 is 9 times 7, and then x to the third power, that's x to the second power times x, and then m to the second power, m to the second power. And the reason I'm saying think about it like that is because we do have a 2 right here. And so these cancel each other out, true, but I have to say absolute value of x. These cancel each other out, but I have to say absolute value of m. These cancel each other out, but I have to say absolute value of m. And then the 3 is going to come out, of course. The 7 has to stay put, and so does this other x. So as far as simplifying that, the m times m, it doesn't matter if those are negative or positive. Since I'm going to square it, I don't have to worry. But the x does need to be an absolute value. Okay, and then the last one, 46, because it's a third root, we're not going to worry about it. You don't have to worry about any of that if that is an odd number. It's just if it's a square root or a fourth root or something like that. As far as am I going to make you write it like that, I don't really care personally. I don't feel like it's something that comes up very often, and so I'm just telling you this because you might see it in other places, and I want you to not be freaked out by the absolute value. That's just what it means. Okay, there is another way that we need to deal with radicals, and so when we have something like square root 5, that we know what that means. It means a number times itself is 5, but there's another way to write that. So the way we can write a radical is we can write it with a fractional exponent. So if we know how to do square root 16, which is 4, this right here, if I just told you that, you may not know what to do, but that actually means exactly the same thing. That is also equal to 4. And so what we have is if we have something like x to the n divided by m power, that is the same thing as x to the n power mth root. So the way you can remember which one goes where, think of roots being on the bottom of something, like something growing out of the ground. So this is my root. Something that has power is on top, so that's going to be my power. And so you have x to the 3/5 power, that's going to be x to the third power 5th root. And so that's one way that we can do that. And so that's really good to know, because if you have to do something like 3/8 to the 1/5 power, and you have to put that in your calculator, even though most of your advanced calculators can do a 5th root, it's probably just as easy to type in 3/8 to the power of 1/5 rather than go through the menus to find the root. So just knowing that is helpful. We can also use that to simplify things. So looking at 47, 5 to the 4/3 power, that means 5 to the 4th power, third root. We can think about that as 5 to the 3rd power times 5. So this comes back to our exponent rules that we had at the very beginning. So this is the same as 5 to the 4th power. And the reason I'm writing it like that is because then those cancel each other out. I have 5. I'm still left with a third root of 5. So that's one way to simplify that. Number 9, I have all of this to the 9th power. So you could write that out 9 times, but another way to do that is we could look what's inside the parentheses. So that's 4 to the first power, fifth root, to the ninth power. And what's my rule for power of a power? It's going to be 4 and 9 times 1/5. And so you can just write it like that. Okay, part C, 18 to the 12/5 power. So that means, 8 to the 12/5 power. That means 8 to the 5/5 times 8 to the 5/5, because that would be 10/5, and then another 2/5. So what I did was I took the 12/5 and I just divided it into wholes. So I have 5/5 and 5/5, which is one whole, or two wholes, I guess, and then plus another 2/5. And so the reason why that's good is because 8 to the first power is just 8. 8 to the first power is just 8. And then I've got 8 to the 2/5 power. So I've got the fifth root of 8 to the second power. That's not simplified all the way. I'm going to take my 8 times my 8, and then inside the radical, I've got 8 times 8, and I can take out another 2, and then have fifth root of 2. So I'm going to have 128 fifth root of 2. So the directions say to write your exponential problems with rational exponents as a radical, and then vice versa. This is how you would write that as a radical. Okay, going to part D. You're going to be expected to do problems like this with no calculator, and so it's going to be important that you can work this out. So I've got the square root of 16 to the third power. So there's a couple ways you can think about it. Think about what the square root of 16 is. It's 4. To the third power, you know that one. So that's one way you could do that. Another way you could do that is you know that 16 is 4 to the second power, and then it's to the 1/2 power because it's the square root. So that just takes care of what's inside the parentheses. And then to the third power, like that. So take a look at that. That's what that is. So here, if I use my power of a power rule, I'm going to multiply my exponent. So that's 4 to the first power, and then to the third power, again, 64. Okay, part E, 3x in parentheses to the 1/2 power. That means the square root of 3x. And there's nothing else you can do with that. F, the seventh root of 4. So I need to write that with a fractional exponent. So it's going to be 4 to the first power, seventh root. Or you could write 2 to the second power, seventh root, which is 2 to the 2/7 power. Both of those would actually be correct. Okay, part G. Think about what you know about your exponents. So in part G, I'm seeing power of a power right here. But 4 also gets the 2/5 power. So I've got 4, which is 2 to the second power to the 2/5. And then y to the second power to the 2/5. Sometimes it's a lot easier to think about these things broken up. So it's going to be 2y to the 4/5. Now, if I would have left the 4 alone and not written as 2 to the second power, my answer would look slightly different. Okay, if I would have just written a 4 right there, then I'm going to have 4 to the 2/5 power. And there's nothing I can do with that because 4 squared is 16, and there's no fifth root of that. And then y to the 4/5 power. So then I can't write it all in one set of parentheses. So I just have to leave it like that. Which, that's not wrong. It's just maybe not the best way to do it. So if you're on the lookout for things that you can write as exponents, you can kind of shorten things up a little bit. Okay, for h, we've got 5b is inside. It is the eighth root of that. So I'm going to have 5b to the 1/8 power, and then it's to the third power. So it's going to be 5b to the 3 times 1/8, so 3/8 power. And if you were to think about, could you do any more with that? this is saying that you've got 5 to the third power 8th root. So 5 to the third power is 125. Can you find an 8th root of that? So since this is 5 times 5 times 5, there's nothing you're going to be able to break that down to that's of any use at all. B to the third power 8th root, same thing. So this is the answer you're going to want to give.